Okay, so the next concept will be acceleration. And the unit for it is meter per second squared. You can also write the same thing like this. So meters per second per second. So let's say the acceleration is 10 meters per second squared. It means that velocity changes 10 meters per second per second. Of course, acceleration doesn't really have mass in it, but we need something else here. Okay, so the general formula for Newton's second law looks like this. So it is change in momentum per change in time. Sigma over here means the sum of forces. So you just calculate all the forces, which you also have to see which way they go. But you take all the forces that act on the disk. If there is a resultant force in some direction, the momentum of that disk is gonna change in that direction. It's basically taking this formula mv and then dividing it with t. And what do you get if you take v divided by t? Then you get acceleration. The acceleration formula is delta v per delta t. You know, the only reason we really have delta p there is because sometimes it's not the velocity that changes. Sometimes it is the mass that changes, or both. So for example, a space rocket, it's gonna shoot that fuel out of the end of the rocket, so the mass is gonna go down, or at the same time the speed is going up, or the velocity is going up. So in that case, it's actually both that are changing. In most cases, it's only the velocity that is changing. Again, someone might think like, why is he putting a freaking delta there? It's basically for those cases where you are already going at some speed. Let's say you're driving a car and then you start to accelerate. So you need, of course, in those equations, you need to make sure you remember to put the velocity in beginning. You don't want to get that mistake there. But anyway, let's dumb it down. Let's simplify it down a bit and just write F equals m times a. New one here, it's force, and the unit of force is newtons, big N, but it's also kilograms times meter per second squared. So of course now we are talking about the driving force. You applying force on a disk. We have to go a little bit further from here. So from this equation we get F per m. It tells you that of course if you put more force on the disk, it's gonna accelerate quicker. But it also tells if you have a bigger mass, then it's not going to accelerate so fast. So the physics tells us that the lighter the disk, then it's easier to accelerate it. It's easier to get a higher release velocity. I should really take out the speed gun, change different objects of different way to find like the perfect way for me, because I think there will be physiological things also, like if I'm just throwing my hand like this, so in theory that's the highest velocity that I will get for my hand, to have nothing there. But of course it might actually hurt me if I don't have a disk there. So I think it's worth to try out what mass gives you the highest release velocity. Of course, you might have different forces applying on the disk than just the force of the throw.
So here I go on about the different forces that are acting on a disk. The most important point for this video is that most forces are deaccelerating the disk. They are so-called resistant forces. Therefore, the benefit of using a lighter disk is counteracted by the resistant forces, most importantly air resistance. It is also worth noting that the only forces that can accelerate the disc are force of throw and gravity if you are throwing downhill. Wind is also a form of air resistance and can sometimes accelerate the disc, but most likely it will be sideways acceleration. We will go over the properties of some of these forces in future videos.